back. So in this video we are going to understand the solution of largest divisible subset, and this question has been asked in the daily contest questions on the 6th of this April, 6th April, on this month, right? So I have not solved this problem because I was traveling, and so I thought I will create this video. So I have gone through the details, and you can see the question is saying that given a set of distinct positive integers nums, return the largest subset answer such that every pair answer I and answer j, right? This is a pair of answer at I and comma answer j. So there is two elements for this pair, and of the elements of this subset that satisfy, if we divide each other, it will come 0. As you can see, answer at I, we are going divisibility checking, right? It is completely coming 0, right? It is completely divisible. So if there are multiple solutions, we have to return any of them. So for example, we have given nums 1 2 3, so we are getting 1 2, and why we are getting, so either we will it will come 1 2 or 1 3. so if we will do divisibility, we will get the same value as a 0, and so it is coming. Similarly, it is coming for 1 2 4 8. If you do that, you will also find that this is the one of the solution, right? So there can be multiple solution, but you can provide any of these, right? So I'll go through this implementation, that how I have done. So first of all, you have to understand the goal, right? So what is our goal? Our goal is to find the largest subset from the given numbers, right? What we have given in the nums, right? From there we have to find the largest subset from these given numbers, or you can say elements, right? So for a pair, that will come for answer at I, answer at j, right? So for every pair, let's suppose answer at I is a and answer at j is b. Okay, so for every pair, let's suppose there is two elements a and b in the subset, you can say, right? So either we will do divisibility a by b like this, or b by a, right? It should come what? It should come 0, right? Okay, now we'll go through step by step code understand, so you will easily do the solution. Why I'm going through? Because if you are a beginner, that you are going to solve the first time a DP problem, you will not face the problem, and you will be happy that you can also solve in the future. Okay, coming back to the step first, why I have written array.sort, right? To sort the input array to handle the divisibility easily, right? Why? Because sorting helps if a, like two elements is there, a and b, right? If a divides b, right, and usually what it happens, a is less than b, right? If two elements is there, a and b, for this example, if we are calling answer at I is a, answer at b is what? Is b, answer at j is b, right? So if it divides a, if a divides b, usually what happens, a is smaller, right, and b is bigger, right? So this makes checking, you can say, divisibility easier in left to right loop, you can say. Okay, and so it will become easy for us to check the divisibility is happening or not happening. Okay, further we will create array to store dp previous and dp array, right? Two things we have, dp, you can say this and this, right? So our main focus is to create the two arrays, dp and prev, you can say previous. Okay, so what we are doing here, so we will use dp here to store the length of the largest subset ending at index I. Okay, so at index I, we have to store the length of the largest subset that we have, that we will store at dp. Okay, what we will store here, we will store the length of the largest subset ending at the index I. Okay, then what we will store at the previous, we will store at the previous index in the chain of tracing. What we will have in the previous one, that we will store here. And for every number alone is a subset of length 1, right? So we'll store by default value 1, and to initialize the previous one we'll use -1 because there is no parent is there, right? Because there is no parent. So in this way we will first sort the array to check the divisibility easier in a left to right loop, and we'll create two things, dp and previous, right? Why? Because we will store length of the largest subset at index I, right, in the dp, and in the previous we will store the previous index in the chain of tracing, right? That we will store, and this is the thing that we are going to initialize. Further, you can also ask questions like dp at I, how many numbers can we have in the divisibility chain ending at num8, right? Or you can also ask in the previous at I, where did we come from the builds this chain useful to reconnect the path later, right? Why you are asking for the -1, means no parent is there. So that's why you can ask where did we come from to build this chain, and it is useful to reconnect the path later, right? And if you talk about the step 3, so we will do what? Dynamic programming loop we will create here. So we'll create two loop for I will start from 1 and j will start from 0, right? We will check if num at I is divisible by num at j, right? We'll check. So this loop will make a longer chain, right? And so we'll also check dp at I is less than dp at j plus 1. If it is less than, then we will update the length. What is the length? dp at I is dp at j plus 1, right? As I said, what we will do, we will store at dp at I, we will store the length of the largest subset ending at index I, right? And then at previous we will store for the tracer, right, later. That we are doing here. So what does this do? For every number nums at I, we look at all the previous numbers nums at j, where j is less than I, right? Where j is less than I, right? So for every nums at I, we look at all the previous nums we have nums at j, where j is less than I. If nums at I is divisible by nums at j, and let's suppose including it makes a longer chain, we will update the dp at I. Okay, we will update the dp at I, and remember we can come from what? Previous one, right? Previous at I. Gotcha? So these things you have to understand. It is not much complex. You just pause the video, you go through this piece of code, and you will understand, right? What does actually it, what does this do actually? So for every number nums at I, you can say we look at all the previous nums, means nums at j, right? And if nums at I is divisible by nums at j, and including it makes a longer chain, we will update dp at I, and what we have to remember, where from where we have came from. So we can say previous at I, right? Further, in step 4, what we should do, we have to find the index with the largest subset, right? And for that we will take a variable max id, max index. We'll go through the this value, we'll check dp at I is greater than dp at max I. Whatever is it is max, we'll store at max I is at index I. So max id, max index is I. So max index will now point to the end of the largest divisible subset. Got it? And then what we will do, we'll go for the next step. we will do backtracking and we'll build the result. And for that, what we will do, we will create a result, will be do backtracking. If id ex is greater than or equal to 0, we will add the result, we will add the result into results, right? You can set whatever the value will be there, we will add the index, and we will update the max index, right? So what we are doing here, we are doing max index. What we are doing here, we will saying go back in the chain. Max index we will do, go back to the chain, so we will get the value from the chain, right? Then why we are doing reverse collection dot reverse, because we build it backwards. So we'll do result again and we'll return it, right? Hope you like this video, and if you have any doubts, please please add a comment and let me know anything you have in your mind, right? If any idea. Okay, so guys, let's understand about the complexity now, right? So let's go with this. We are taking two loops here. Okay, so see, simply we are going with the two nested loops right here in the steps 3. So what we will do, we have outer loops that runs n times, right? As you can see, from I equal to 1 to n, right? So outer loops runs n times, and inner loops is also runs up to ith time, right? As you can see. So total, if we'll do, we'll say O of n square, right? And in the loop it is going for O of 1 time, that's fine. Yeah, so we can say time complexity is O of n square, and we are only using dp, and dp this value of n size, so time complexity of n. So if I'll go here, tc will be O of n square, and sc equal to O of n. So that's all for now today, and if you have any doubt guys, please ping me in the comment box. I'll see you in the next one. Thank you for watching this video.